morning. This is the first talk, so I hope you are as energetic as I am. You know the drill. This is what you see. Imagine you are in Tomorrowland, Belgium, lost in the music, crowd alive, but you see clouds. So that is what happened exactly on 2022. Tomorrowland, Belgium was in full swing, just like this. The music you heard was the exact music that was playing there. But people see the clouds moving, and they were worried because Tomorrowland and rain doesn't go well. It happened back in 2014. Tomorrowland played something and did like a cannonball just to stop the rain, but 2022 was still a fear. But back in backstage, Armin van Buuren, the DJ, our own DJ, was relaxed. He was chill. He was just sipping the water, and he didn't care about this. So one crew went there and asked, like, why you are so much relaxed? Because maybe there will be a rain when you will start. Then he just saw, okay, this is Buienradar, check this. This is where my set starts. This is how the rain moving, and it will not affect, because he was sure that he was using it. Now, I have the proof as well. So, music.
The rain, when my set starts, it's gone. I'm so happy.
Yeah. Okay, so what is the reason to show this? Apart from all other reasons like show off and everything, one main reason is to show that the impact that we make in hundreds or thousands of people on daily life, I will correct myself, not just hundreds of thousands, millions, 10 millions, 15 million was the last summer, the number of unique users that used our platform, both app and web. But now compare this with the Netherlands population, which is 18 million. We do not expect toddlers and babies to go and worry about weather because they have so many other things to worry about. What does it mean? We get traffic from all over the world, and that's an achievement in itself, because Buienradar is as Dutch as can be. Buien in Dutch means rain, of course, that we mean. What does it mean is like people go outside, promote this magical app, and this is how we get traffic from all over the world. And since June 2024, there is a research going on which brand in Netherlands is making the highest reach in terms of reaching the different population in the Netherlands. Since June 2024, we are a number one brand who is reaching the maximum number of people in whole Netherlands in all categories. As you can see, Eddie, Nu.nl are all after us. And we do not check Facebook and Twitter and X nowadays, but this is mainly for Dutch brands. So this study and the reach is only considering Dutch brands. So that's why I'm here. I'm going to talk about what we do to make this possible. I'm very proud of what we do, and that's why I'm here to show that. But first thing first, who am I? I am Neel Bhatt. I work as a solution architect for Buienradar, so mainly responsible for end-to-end everything about the tech for Buienradar. I also work as a chapter lead for RTL News and Entertainment. What does it mean? I'm responsible for front-end and back-end of both RTL News and Buienradar. I work with very smart people for both of this platform, and I'm mainly responsible for the growth of both, technical growth of both of this platform. I'm also international speaker, just like last week. I spoke for the first time, that's why I put it here, because this is very fresh. I also write blogs, tech blogs mainly on my own website, neelbhatt.com. Also participate in a different community, Microsoft Community, Stack Overflow. And these are all the companies I work with, MasterCard, Coolblue, Buienradar, everything. Now, the interesting part, what I'm going to show, I will first show the product. Will not go too much in detail because I hope people here knows Buienradar. I will show how does the rain radar work. I will show about the top 3 challenges that we face in weather forecasting, the architecture, and the last but not least, the weatherproof engineering. So 10 ways that we do in our platform that helps us to remain on top of the game, basically. The product. So it started in 2006. It was developed by 2 Dutch brothers as part of the hobby project, and they didn't know it will go viral. So in weeks. The website was used by a lot of people in Netherlands. And then the first app was launched in 2008. That was the very first iOS app in whole Netherlands. And that was, the UI was like this. It was acquired by RTL. Not many people know, but Buienradar is part of RTL, and we work with developers from Videoland and RTL News. These are all other online platforms from RTL, and these are all other things that RTL does. Like if you see, for example, an advertisement on Discovery Channel, it goes via RTL product, which is Ad Alliance. What is the vision? So we have very specific vision, and we know what we want. So Buienradar is the most reliable and personal weather assistant on all relevant platforms. Here, there are many things to focus. One is accurate and real-time weather. So weather is upmost the main priority, but all relevant platform is something we are focusing on. So we have Buienradar also in smartwatch. We have in iPad, desktop, anywhere you can see it. And if any new device will be launched tomorrow, we'll try to thrive also to make it possible there. We also tried in Google Home that you can say, hey, what is the weather for today? And it gives back. It was back in 10 years ago, I think. Nobody used it, so we killed it off. But that was also there. Another thing that we want to focus is scalability, because traffic on Buienradar goes like this in the morning. We want our product to be scalable to handle millions of people in a short period of time. And high availability, we want to be there 100%. That is the main focus, even mainly on peak days. If there is a storm and if we cannot show the weather, that's a big shame. That's not what we want. The product, I'll go very fast. Is there anyone here who doesn't know about Buienradar? Let's do that. Oh, that's very daring for you to be here. Nice. I will make sure that you know more. This is for you now. The product. So we support -1 hour. So for where you can see the weather right now, you can also see how lightning is progressing, earthquake happening, anything what is happening now that we cover. We also cover forecast 3 hours, 8 hours, 24 hours, 48 hours, 5 days, 14 days. That's the maximum we show. And we also publish weather reports multiple times in a day, because we have a bunch of meteorologists who has the main focus. If you come to Buienradar office, that's what we talk about, of course, weather. And we have weather maps, but this is most of the people think what Buienradar does, but there is more. You can also have a terrace radar, for example. You can see when to go to terrace. And you can also set an alert. So if you want to go, if you set an alert for terrace, if tomorrow is the best day for, actually today is the best day. So in this case, today morning, you might have received a notification, hey, this is the best day to be in terrace, and this is how you make your plan. We also have different, that are like mosquito radars, sun radar, UV radar, and everything. And for each of these radar, you can set an alert. We also have VZine, which is like a magazine for weather enthusiastic. We have weather photos and videos. People go there and upload the photos and videos. If you have the best photo, it gets highlighted on television. And we also have different competition at the end of the year to choose the best weather photo. And daily news, where RTL also shows Buienradar forecast, live webcams and everything. These are some of the fun facts. Buienradar is the most open weather app. People check Buienradar first thing, even before testing their partners sometimes. And that's what we are thriving for. We want to be the app that people rely on and make their decision for the rest of the day. We have peak usage, 7 to 9. That's what people check before going to school and work. I would not exaggerate if I say that we also cause traffic sometimes on the road, because if there is a bad weather, people decide to go by car. We had the biggest traffic record so far was 85 million page views in a day. And that was like 6.5 million unique users in the span of 12 hours. We have yearly page views 5.8 billion. Our radar updates every 5 minutes. This is how real-time the weather that you see. The user contribute, as I mentioned, people can upload photos and videos. We have like so far 2.1 million photos uploaded by People, sometimes we even wonder maybe people are using this as a backup of their photo library. That's why at one point we needed to restrict there's only 10 photos per day because we do not want to make like a library for photos and videos. The fun part is this is managed by a team of 7 developers. We are not a big team. We are just 7 of us who takes care about this, along with people from RTL, like platform engineering, of course. There are another 5 people, so small team making this big impact, and that's what I want to show you today, like how we do it. We have 80 plus radars, so it's not just about rain, as I mentioned. There are many things that we do for weather, and we send millions of alerts every day for each of these users. And the last but not least, we also support Street View. Many people do not know that, but you can also see the weather for your street. I will show 2 things, one about the development team. I do not want to show the real face and name, but these are the people like look-alike, and imagine the impact that we make if you have Professor Vin Diesel and Supergirl, basically, for iOS development. And this is the part that I want to show. So for example, as you can see, you can go to directly on a street. Right now, we are focusing on Amsterdam. If you go to like Amsterdam Central, as the video shows, you see the rain moving like in some time now. But if you go a little bit like 1 kilometer away from Central, then you don't see the rain. So if you just search for Amsterdam, it's not accurate. You also sometimes need to choose the current location, because sometimes we get a lot of feedback like, hey, I got wet, even if Buienradar says there will be no rain. Because like this, you need to choose a current location, because then only we can predict exact your location. Or you can choose your street as well. So how does the rain radar work? There are actually 2 radars owned by KNMI. We love KNMI. And this are in Den Helder and Herwijnen. So this, what it does, it scans entire sky every 5 minutes, 24 hours a day, looking for precipitation. And what happens when the radar sees a precipitation? So radar transmits a radio wave. Whenever there is a precipitation, it reflects back. And the distance from where it was reflected back decides how far the rain is based on longitude and latitude. And the strength also determines how heavy the rain is. So that's how we define millimeter and how bad or good the rain is. And this is a little bit about the nowcast. We do or start from 0.3 angle to 90 degree. So this is how the radar scans all the environment, because below 0.3 degree, we do not expect cloud to be there. And that's how nowcast work. But the forecast is even more interesting. Nowcast ends for 1 or 2 hours, because after 1 or 2 hours, we do not have that much great prediction of rain is moving on. That's why we rely on forecast from 3 hours until 36 hours, 48 hours. We rely on this particular model. What does it do is like it creates grid of 10 to 20 kilometers horizontal and vertical. So it's like every location on this whole world is divided into this grid. And we keep in mind about humidity, clouds, and everything. So every time this particular supercomputer or the machine runs and checks how the different location based on all the different variables in mind, and this is how we determine the forecast. So there are different modeling for this. We rely on these models. We are also experimenting AI modeling in future to see how AI can predict instead of this, but we will see. Not there yet. Our top 3 challenges. So first challenge that we face is false echoes. I'm going to disappoint flat Earth believers if they are here, because flat is not Earth, it's curve, and that's what it happens. We expect radio wave to go to cloud, but because of the curve on the Earth, it goes and somewhere on the Earth. Sometimes when there is tree with rain, the radar thinks it's rain, because it thinks that there is a precipitation and that a signal is reflected back. And that's why it creates lots of echoes. So If we rely only on the radar, this is what we will end up. That's why we do not only rely on radar. We have our smart algorithm or calculation. We have meteorologists also, of course. And we created algorithm altogether to filter it out and to understand what is real weather and what is not. We also have a system from where you can cluster out or filter out all these things that you think is not rain. And we do not only rely on radars. On Netherlands, we also get data from UK, we get data from Germany, you can data from Belgium, nowadays also for France, and we combine all this data and create the weather or the images. Second challenge that we face is the drizzle, because sometimes people say, oh, it's raining, but the Buienradar doesn't show rain because we have separate radar for that. It's called drizzle radar. There was one post which went viral. Somebody mentioned like, there is a drizzle radar and thank me later. And it was in Reddit and it got viral, and after that many people got to know that there is a drizzle radar in Buienradar. But there is a challenge. Radio wave transmits, it cannot detect small droplets because drizzle is a very small, and that's why it just passes through it. Or if the radar is there, and we know Netherlands is below the sea level, so some of the locations are even below the radar view, and that's why it cannot detect. So what we do, again with some of the calculation that we do, we also relied on satellite images. So that's why for drizzle we do not rely on rain radar, but we rely on our own calculation based on ground temperature or different variables. Basically, we determine that right now there is drizzling. And we also have satellite data, and we combine all of this and show it. Not many weather apps do that, but this is something that we do uniquely. Third thing is about thunderstorms. We call, or our meteorologists call that like a popcorn cloud. You cannot always predict thunderstorms in advance. Thunderstorm is a disturbance when a plus like charged particles and minus charged particles collide because of the how the wind is, and this is how the thunderstorms are created. But again, it's not very easy to predict. This is one of our challenge. We still show it because of all of the calculation that we did, but it's only now. We cannot predict for future. We were working or are working to create a forecast for thunderstorm, but this is so far our biggest challenge and something we want to improve in the future. Now, the architecture. So far it was all about weather, but now it will start the tech part and also where my skills are. We have two main parts. One is about API and other is about data processing. I will show both of that. And this is the text that we use. We are .NET branch or shop, you can say. We use Docker, we use Kubernetes, we use Grafana, we use Prometheus, we use React in front end. I will show all of this. First thing first, API, which is very basic architecture. We keep it very basic because we want our API to do only one thing. User asks for something, it goes to API gateway, and these are all the bunch of APIs that we have. API goes and checks in cache. If the cache data is not there, it goes to storage and update the cache, and this is how we want. In a way, we want our APIs to be as dumb as possible because we do not want to put any logic or business logic or any calculation because we want a user to see the lightning fast response, and we do most of the things in background. And that's what our background job does. And this one is more detailed architecture. What you see in up is how we do the data processing. We rely on different sources. We get data from radars. We get data from supercomputers. So all the modeling, models of machine learning for forecasting. We get data from also sometimes from government. If a child goes missing in Netherlands, we also show it as we call it Amber Alert. We get all this data from different sources. We have a bunch of microservices. We call it processing, which processes each of them, some of them every minute, some of them every 5 minutes, some of them every hour. And as you can see, we separate them in terms of weather. So some of the application is really literally called sun, some of them rain, some of them cloud. And all of them are processed, we call it combiner. So we combine some of the data source because, as I said, we only do not rely on Netherlands, we also rely on data from Germany and everything else. We have different cron jobs that creates all the intelligent things or the algorithm part. And for example, pollen index. How can you define if there will be pollen for tomorrow? So these are all the logic that are done by these cron jobs. And at the end of this, it creates either the images or the data that goes to storage, which is used by API. When API interacts with storage, there is also circuit breaking, retry everything, which I will show in the 10 techniques that we do. And we use Grafana a lot. We rely on Kubernetes, and there is a management console from there. Also, meteorologists can change anything if they want. It does not mean we change the weather, I hope, but it's mainly so that we can filter out some of the things, as I mentioned initially. Now the fun part. What I will show is all the 10 ways to build the system that is ready for any storm. Just like I asked AI to create something on Mars to create a weatherproof architecture, and this is what we want to build. So I will need your imagination. So if you want to create this particular architecture on a planet where there is a lot of bad weather, so what do we do? So these are exact steps that we do, and this also helps us in terms of tech. So first thing first, we need to establish the ground rules. That's what we do. We define way of working. We have everything that we want. Everything is there. I will show, but it's clear, and this is how we believe that it should be. We need solid foundation, and we defined Kubernetes at the core because that has proven to be the best choice so far. Again, I will show once you have solid foundation and the ground rules, that we need clear direction because this is how you create a structure. We have a clear and collaborative solution architecture. I will show how and what we do for that. We do smart deployments. I will show how we do deployment strategically using all these techniques. After all of this, we need to keep an eye on weather. So this is why observability, I will show how we observe whenever, how the traffic is going and everything. We need to make sure that we are designed to handle failures. This is a storm-proof system. I will show how resilient our systems are. I will show how we do the auto-scaling because, as I mentioned, traffic goes very fast up and down. Even after all this preparation, there is impact. There is always something that goes wrong, and that's how I will show like how and what we do in case of failures. After all this, I will show how fast our APIs are and what we do for that to keep the latency low. And at the end of the day, or end of this, all feature versus tech depths. So how we decide what to work on as part of the maintenance. First thing first, establish the ground rules, define way of working, why it was required. When I joined RTL 2022, there were many things going on. We had very good hope, we had very good plans. We want to go to Kubernetes, we want to be #1 weather platform. But remember again, we are just 7 of us. At that time, even 1 person we were hiring, so just 6 of us. At that time, it was really required to have a straightforward direction or straightforward way of working. Because we do not want a discussion that goes for a PR, for example. If you raise a PR, there are so many things. We want to have a specific, concrete direction for that. What we do for that, I know it's not much readable, but that's intentional. We have this way of working in our Confluence. What does it contain? It contains agile practices, Git flow, how we do the deployments, how we do the documentation, how we do incident management, how we do technical depths, how we define that, what we do for learning and innovation, communication, state of engineering, and chapter goals. Every year, starting of the year, we decide what we are going to work as a chapter because we use Spotify model. Even Spotify stopped it, but we continued, and this is working for us so far. I want to highlight one thing, state of engineering. Every 3 months, we ask our developers specific 12 questions. 12 questions are always similar, that doesn't change. But what is the main focus? We ask, and we want to see throughout the day, throughout the year, what is the trend? So what are these questions? So I didn't mention all of them, but some of them is like, how easy is the release? How suitable our processes are? How much good our health of our code base is? Every 3 months, people rate it. We do not forget the result, of course. When the result is out, we talk with each other, what we can do for this, how we can improve this. At the end of the year, our target is to improve, and that's what we believe, that there should be improvement. And that's why we have this, not just for Buienradar, it is for RTL throughout, for all the chapters, and that helps us a lot. Once we have way of working set up, solid foundation. Again, back in 2022, when I joined on my first day, my manager told me, we have a solid plan to go to Kubernetes. And I was excited. OK, that's good, because this is what I want to do as well. When I went back to reality and saw the code base, we were not there yet. When I wanted to deploy something for one of API I call a graph data, there was a downtime when the deployment was going on. And at that moment, I said, OK, I said yes to my manager, but it will be a long journey. That's why we decided, OK, we need to have a plan. We are going to Kubernetes. And it's not just about Kubernetes. As is mentioned, it's about transforming how we build, deploy, and scale. Because so far, what we are thinking now, our thought process is all about ports and nodes. We started thinking about how we can improve scaling, how we can improve the deployments, and this is how the transformation began. Before going to transformation, I would like to show where we were. So it started in 2008. It was a big monolith until 2019. It was working, of course. There are some people here using Buienradar for a long time, it was working. But it was a pain. If something goes wrong, it was visible for the users. So from 2019, my forefathers, people before me, decided to convert all this into microservices, which was a good decision, because after this, splitting into service, better scaling, overhead has improved a lot. So instead of having just 2 APIs, we had now like 15 APIs. That was not it, of course. We wanted to go to Kubernetes, as I mentioned, and Docker was the part of that, because we wanted to have a standardized deployments, containerization, and that's only possible if we have things on Docker. And that was a stepping step into Kubernetes. And after Kubernetes, auto-scaling, self-healing, I will show in a bit, but that helps, and this is exactly what we wanted to do. So when there was monolith, there were only 2 of the APIs, data API and image API. If one of these API fails, you do not see anything. But now, from 2019, for each of these spaces, if you open a Buienradar app, if you saw on top, that goes from different API. If you see anything else, these are all different microservices that runs. What does it mean? If photo and video API is down, it does not affect anything. It just breaks that particular part, and everything else runs as it is. But the Kubernetes part that we wanted to go, why did we move? Because one is cool. Of course, nowadays, everyone is talking about Kubernetes, but only we didn't want to do is because it's cool. We wanted to do it for scalability and performance. Before going to Kubernetes, whenever there is a bad weather, we needed to manually go to one of our console, click on 7 a.m. until 11 p.m. We want our Azure instances and everything from 3 to 10, for example. This is the scaling that we were doing. But as you can imagine, even the bad weather is only until 6 p.m. We were putting it until 11 p.m. So we are giving all of our money to Azure. And they were liking it, of course, but we didn't. That's why auto-scaling is something we really need. And Kubernetes provide that very well. We have aggressive auto-scaling, I will show in a little bit later part. High availability, we want our ports or everything self-healing. If something goes wrong, product owner asks us, one thing that we do from our IT mindset is restart. Because if you just turn it off and on, most of the time it works. But nowadays we don't do it manually. Our Kubernetes does that. If something is giving 500 errors or everything, our ports are self-healing. It just creates another ports, it kills the other one, and this is what helps in high availability. Zero downtime, when we want to publish something, we do not want any downtime. Imagine, I already mentioned before, 3 years, it was a different picture, but this is the journey we chose, and this is the outcome or the fruit that we get. Cost optimization, I already mentioned. We do not want to reduce a lot of money. We do not want to give our money to Microsoft or to Azure. Faster deployments, I will show it in a little bit, these two things, so that's why I will not go in detail. Security is the main thing. We many times see people are trying to bombard our services. I don't know why, but people just like to create crawlers and to bombard with some of our applications. With Kubernetes, we can even put more security on all the ports and everything, so our ports and all our applications are not compromised, or at least that's what we are targeting for. I hope no one will take a challenge from this audience and try to break it. Please don't do that. Cloud native and portability, already mentioned, so that's the hybrid approach that we took. And this is how our structure looks like. Is there anybody here who knows about GitOps and Argo CD? Okay, only 3 of you, nice. After this, I would recommend people from here to use that or give it a try. What we do, so whenever somebody creates a PR, our pipeline runs automatically, of course. It creates an image. It goes to and checks in GitOps. In a nutshell, if I try to explain GitOps Argo CD, it's like a kitchen. There is a recipe book, which is GitOps, where you can define everything that you want to do from your infrastructure. It can be, I want to give 5 minimum ports, so whenever there is like a normal weather, it's 5, but if there is a bad weather, it should go to 50 ports, for example. In a nutshell, GitOps is a recipe book where you define all of your infrastructure as code, and Argo CD is a chef that checks this recipe book and implements and does all the things. So now imagine the thing that we were doing manually. Whenever there is bad weather, we were going and doing this manually, upscaling, but this is done by Argo CD. So, and it's open source. It doesn't cost that much. What does it do? It checks GitOps. It creates or kills the ports based on how we define. And good part is there is a UI. You can see literally when the ports and nodes are getting killed and self-healing. And you can also have like different, this is what we have, test, acceptance, production, and we have load balancing for west and north. Again, I would highly recommend, if you're using Kubernetes, check GitOps, check Argo CD, because that's really useful. When we have, once we have a foundation clear, once we have way of working clear, we want to focus on having repeatable, scalable, and predictable architecture. Before some time, we decided, okay, we want to go with MongoDB, for example, one hypothetical situation. And after 1 year, somebody else says, hey, well, let's try Postgre, or hey, let's try vector database. That's exactly what we don't want. If we decide on something, at least and until it is working fine, and at least and until we find something that has proven to be good, then only we change the architecture. First thing first, for coding, when you go to any of a Buienradar app or repo, the architecture that you see is similar. That is intentional. We do not want a new person who onboards gets confused with all different architecture in one place and all different architecture in different place. That's why we decided we want hexagonal / clean architecture. What does it mean? This is exactly how most of our repo looks like. We have API layer, we have core layer, which is the business logic. We do not keep lots of business logic, as I already mentioned, but still there are some just to combine the things. And then there are adapters, plug and play. So these are all the external library, external dependency that this API rely on. We put it on different things so that it also becomes it's good to read, basically, when you read the code, because we do not write code for machine, we write code for humans. And that's why we want to make it readable. We also tried vertical slice. We also tried all different architecture. It didn't work as much as it worked for hexagonal for us. But this is not it. We are focusing at least to have a domain-driven design. There is one Disney-driven development talk today, so I'm curious how it will be. But DDD is something that we focus on. What does it mean? It's very simple. If you go to talk to your product owner, if you both speak the same language, then you are going on a correct direction of domain-driven design. Because we want our business to talk the same language as we do. If you are talking about forecast, they also know it's a forecast. If you are talking about weed scene, they should know. So this is exactly what we want to create, like define different domains, and we want our business to also understand the same language. We are putting the choice between Microsoft architect. We are not, of course, that we always want Microsoft. It's not like that. Based on the situation or the problem, or that's how our solution is there. But we have different options in place where people or the developer can decide which is good and which is not good. We have technology radar in RTL. If you want to introduce something, it goes in different phases: adopt, accept, and everything, or reject. That's why we do not immediately introduce something new, but it goes by some of the layers. And the last thing that I want to show is the ADR, because we believe a lot in writing ADR. What does it mean? Architecture Decision Records. The reason is I do not want my future self or future developers to wonder, why did we decide on MongoDB? Why did we decide on Kubernetes? Because that was the challenge for me when I joined, 2022 again. There were some of the decisions taken by previous tech leads or developers, which was, of course, I can understand that has worked, but I wanted to know why, and that's always not clear. And that's why we started writing ADR, and this was the first ADR we said, okay, we will write an ADR. And that was the ADR for an ADR, and that was accepted, as you can see. In simple words, if you are taking any architecture decision, it's good that you write it down, not for you, but for your future self, because for you, it's very obvious what you use and what you don't, but not for other people who are going to join. So again, back to architecture part, it does not mean that we are rigid. It does not mean we are very strict. What it means, we have a very specific direction in terms of architecture. If you want to introduce something new, use ADR, discuss it with other tech leads. If it gets accepted, then we work on it. We do not want one developer to work on C# and another developer to work on F#, because of obvious reasons. That's why we have, and that works for us, of course. Smart deployments. There are two types of pet deployments, those that go wrong and those that go unnoticed. That has proven for us as well. There is one way to know that something is breaking and one way to realize that unnoticed part and your user let you know that, hey, this is breaking. What we do for that, we use canary release. Does anyone know about canary release here? Okay, nice. So canary is a bird. In 1800, when people were used to go in mines, they were used to carry this bird with them. The reason is canary bird is very much affected when there is carbon monoxide in the atmosphere. So whenever there is this gas, this bird feels uncomfortable. And this is how people at that time, with very selfish reason, I know, I don't like it, but because of this, they realize that there is carbon monoxide and they go back from that mine. Previously, they were doing it without this cage, but I used it the more human approach, and they use this cage so that bird also do not die. But canary release is, yes. Oh, 5 minutes. Oh, it goes fast. Canary release is something that we use for deployments. So if something we roll out and if it doesn't work well, then we go back, of course. I need to go fast. Maybe we'll not have time for questions, but I'll try. Apart from canary release, we also use SLO alerts. Whenever something burns very fast, we get alerted. And we use feature flags. We do not just have a big release. We have like enabling and disabling feature flags, and that's what we believe. We do not want to have big bang release. GitOps and Argo CD I already mentioned, but this is what we also use for deployments. Observability, because we do not want to guess what broke at 3 a.m. If you did it, then you know the pain. We use OpenTelemetry. It is an open source framework where you can plug anything from your code, and then you can plug Splunk, Datadog, or anything. In our case, it's Grafana. This is how our observability looks like. From Argo CD, it goes to port. All of this port puts everything to OpenTelemetry, what it goes, where it goes to Grafana. If there's metrics, it goes to Mimir. If it goes logs, it goes to Loki. These are the terms that Grafana uses. And this is how our dashboard looks like. It's fine, it is not readable, it's intentional, but the main reason is to show we can see all of our API, how it is performing in terms of ports, in terms of latency, in terms of number of errors. If something turns red, that this is how we know things are not working. But this is not it. We can also see app metrics for each of this. You can see what are the usage, how many ports are there, how many logs, or we can visualize everything from this particular part for each of this API. And we can also see the error logs and everything. From this, we can see, OK, things are not working fine. Let's create a task to improve this. But we also use Grafana for missing location. At one point, we realized that there are some locations which are missing, and this is how we know. Designed to handle failures, because something will fail, and it's like when and how you recover. So we use different techniques, circuit breakers, retry, timeout. If a service is not working, we do not want to bombard the service. We want to stop at one point, let the service to recover, and then start the flow. We also use the self-healing ports I already mentioned, but this is in action because we want to see the things in action and not just in paper. That's why what you see circuit breakers, again in Grafana, we can visualize whenever circuit is open, it turns open, red, and this is how we can see retry, timeout, everything, self-healing in action. As I mentioned, manual restart is not required. Whenever there is a problem, it restarts by itself, and thing just moves without us doing anything. Auto-scaling, because traffic on Buienradar often increases rapidly. This is how you see the traffic from 7 a.m. to almost at 4 p.m. And that's why we needed a very aggressive auto-scaling. So this is one example of one of our graph data API. Somewhere around 9 p.m., we see a lot of traffic because the next day was very bad in weather. Our ports from 8 increase dramatically to 50, just to make sure the traffic is, so that's why the user do not see anything. But the best part I like is it goes down, and there's the cost we don't want to give away to Microsoft. That's the burning part, and that's how we want to make sure that it goes up, but it also comes down. That's the most important part. Again, 99.9% still means 8 hours of downtime. So even if you do something, everything, there are some people, there are some moments that things break, and too bad that customer remembers all of them. With Buienradar, that's the pain. Whenever we make a mistake, we go viral because people have lots of trust on us. They do not want to fail. And if you remember some of this in 2022, this happened. Suddenly in October, we were showing temperature of 36. And this is how different news channels started showing. Some of the people also messaged me like, hey, why are you messing up? OK, fine, it's not us. But this is what we do for failures. We have PagerDuty integration. Whenever something goes wrong, we get automated alert. We do not want our user to tell us. We want our system to tell us when something goes wrong. Alerts are, you get a call, actually, literally a call when something goes wrong. You have to accept. You don't accept, it goes and calls somebody else. So you cannot go away from that. Only for P1 and P2, we do not want to get this call for everything else. These are different pager duty. I will just skip for now, but just to visualize that we have this P1 incident and how fast we did it. But this is not it. We have PRTG integration. Now think about all the data processing, sun, rain, and everything. We also want to make sure that files are not delayed. And for that, we create an alert for each of them. We do not have aggressive alerting for all of them. As you can see, limit is based on, yeah, I think I'm moving the time. But this is how we define and have the failures. Postmortem, I need to go fast, keep the latency low. We use caching a lot of caching. And we have async processing. This is how most of the time we use Elastic and MongoDB to make sure that our performance is fast. Feature versus tech debt. Tech debt is something we do not ignore because priority, we define WSJ for that to see what is weightage in terms of that. And features, these are all the features that we worked on. Always innovate. We have Shark Tank for that. This is the last slide. We are working on AI, a lot of AI. We are not just going back to the buzz, but we really want to work on something that helps in weather tech. We recently created a weather translation. So if you are English speaking, if you go to Buienradar, now you can see weather report in English. That is due to AI. If you go to and search Paris, you see a weather report that is created by AI. We are working on weather assistant that you can ask something and that gives, but this is in flow. But these are all the things that is working on. And if I am standing here after 1 year, things will be totally different for weather tech. That is it. Thank you. And this is how you can rate, if you want to rate my task. And I think we don't have time for questions, but I will be here if you have any questions, and if you're wondering something, reach out.